Hey guys, welcome to today's lesson. Today we're looking at the fourth video in the set of sequences and series, looking at the sum of a geometrical progression. Now if you didn't watch video 3, okay, we looked at the general term of a GP. I'd advise you to go back and have a quick look at that. We basically went through what is a GP and went the whole fact that there is a common ratio R, and that we find R by looking at the quotient or the division of the two terms, okay, and we're kind of proving that by saying u3 divided by u2 is u2 equals u1, therefore it is a GP. Remember the GP has that common ratio. We use the example 5, 10, 20, 40, okay, 80, where it's being multiplied by 2. It could be going backwards, it could be like a fraction, like a half, etc. We then came up with a rule for for UN, which was u1 times r to the n minus 1. Okay, and that allowed us to find whatever term that we actually wanted to have. So today's lesson, we're looking at the sum of the geometrical progression, or in other words, the series. Okay, hopefully remember that's the difference between a sum of the sequence and the series. This series, we're using that sum of symbol, I guess, and we're adding up all these numbers. So it would be something like 5 plus 10 plus 20 plus 40. I'm going to call this a finite series as well, because I can't just say add up the entire series, because it is increasing, which means it would be approaching infinity, wouldn't kind of work. So we'll most likely be looking at questions, well, not most likely, we'll be looking at questions where we might say, for this particular series, add up, find the sum of the first 20 terms. Okay, so how do we do that? Well, of course, we go back to looking at formulas and rules and those types of things. Now, the formulas that we use are a bit more complex, and this time I'm not going to show you where they come from, but of course, if you'd like to, I can do those videos for you. But for us, we don't need to prove this formula, but we do need to know how to use it. There are two formulas that we generally use. There are, well, depending on what our ratio is going to be. The first one, we have our u1, that's our first term, we remember in our series, and then we have r to the n minus 1 over r minus 1. The second formula we have is very similar. It's our first term, but it's 1 minus r to the power of n over 1 minus r. And you might think, well, why they look so similar? What's the difference apart from the r's and the 1 swapping around? That we generally use this when our ratio is greater than 1, and we use this when our ratio is less than 1. Otherwise, you're going to start dealing with negative numbers, and we're trying to avoid that. Also noticing that if r is equal to 1, then this is going to equal 0, and you're just going to have u1. But yeah, and it's going to get divided by 0. It's not going to work too well. So we won't have r is equal to 1 either. So they're the two formulas that we need to use. So let's look at an example of a question. Okay, for the most part, like you've seen, the questions are generally pretty straightforward. So example 1, we might find the sum of the first 12 terms of this GP. Okay, I'm going to give you what, let's say we'll do 2, add 6, add 18, add 54, add ... ellipsis. Okay, that's my question. So first of all, we are told that this is a GP. We don't need to prove it. Of course, if you wanted to prove it, all I would be saying will be r is equal to 6 over 2, which equals to 18 over 6, which is equal to 3. Okay, therefore, GP. So if you had to prove it, there you go. Now, the biggest thing here though, and this is why I quite like to do this anyway, we know that the ratio is 3. There are two pieces of information, or three pieces of information we need to know for this question. We need to know what u1 is equal to. That's our first term. We've got the common ratio now, and we need to know what our n is. In this case, it's 12. Once we've got that, it's pretty much just plug and play. Noticing here that our ratio is greater than 1. So I'm going to choose this formula up here. Alright, so I'm going to do it up the top here. So I'm going to say the sum of the first 12 terms is equal to my first term of 2, and then it's got times our ratio of 3 times to the power of n, well, it's to the power of 12, take away 1, all over, and then it's going to be our ratio again, which is 3, take away 1. A lot of time people just put 2 there. They just simplify that. Okay, doesn't really matter what you do. And then I'm going to simply put in my calculator, and we get 531,440. So 531,440, which is a fairly significant sum, and it's only 12 terms. Think this is an exponential kind of equation. It's going to grow exponentially. All right. So that's your first type of question. So that's pretty straightforward. You just need to know which formula you're putting into. What's a more challenging formula, or more challenging questions, should I say? So look at this one. If you want to maybe pause it, you can have a crack at it. 9 minus 3 plus 1 minus a third plus ... Okay. And I'm going to say find an expression. Find an expression for the first, so the sum of the first n terms. Alright, so this is one where I just want a formula, basically. Of course, if we're asked to show that this is a GP, I'm always going to say this, guys, because I think it's important. We're going to say -3 on 9 is equal to, well, let's say that's going to be, well, we can say 1 over -3, which equals, well, 1 over -3. Isn't that right? So equals -1 on 3. We've shown that they're both the same thing. I could do them separately, but I didn't have to do that. I could even choose -1 on 3 on 1, but that's a GP. I've shown basically that our U2 over U1 is equal to U3 over U2. All right. So once again, if we're asked to do that, we can do it. If it doesn't tell us that's a GP, and theoretically this question it doesn't say it's a GP, so we kind of should be saying that. But we want to find an expression for the sum of the first n terms. So I need to have our 3 pieces of information. I need to know what my U1 is. It's 9. I need to know what my common ratio is. We know it's -1/3 now that we've done that process. And n, well, that's just going to be n. Now I need to select one of the two equations, or one or two of the formulas, noticing that my rate, okay, is less than 1. So that means when I do this, I'm going to enter it in as my U1, well, that's 9, brackets, 1 minus my rate of -1 on 3 to the power of n, all over 1 minus my -1 on 3. Now I can simplify it slightly, not a whole lot unfortunately. I might even use square brackets here just to distinguish between what's going on here. I can't change that to a plus at this point in time because that n is a power of -1/3, so I've got to be careful there. But I can put this as 4 on 3 if I wanted to. Now that's 1 minus -1 on 3. I'm going to give you a little bit of a pointer here. Something that's going to make life easier down the track when you have application questions. I don't like having this divided by 4/3 on the bottom. So what I can do is I can simplify this 9 divided by 4 on 3. Now your calculator will do that nicely for you. Okay, if you simply type in 9 divided by 4 on 3. Otherwise, you might remember that's dividing by a fraction. We can times and tip. Okay, which means we could simplify this to be 27 brackets 1 minus brackets -1/3 to the power of n all over, and now I've just got that 4 on the bottom there, and it's just a bit more simplified, you know what I mean? Like it's a little bit nicer, and it might not matter so much for this question, but certainly for later on it just makes life just a little bit easier. So again, that's two different style of questions. That one, if you wanted to find the sum of the first 20 terms, I'm just throwing a 20 in where the n is. So there's not a whole lot difference from what we just saw in that previous question, except that the ratio, the common ratio for that GP, was less than 1. So I guess you might say, well, let's say for our third example, what is a really challenging question? So perhaps we might say something like this. A GP, let's say, has U1 equals 5 and r is equal to 2. The sum of the first n terms is 635. Find n. So you've seen these reversal questions, guys, and you really need to get the hang of them. But I think what it's important to do is to go through that process. Number one, is this an AP or a GP? Well, we're being told this is a GP. Am I finding an nth term? Or am I finding the sum? Well, I'm seeing this sum bit here. So when I'm seeing that, one of the first things I'm thinking about, well, is my sum formula. But of course, we have two sum formulas. We have 1 minus r to the power of n and r to the n minus 1. That comes down to having this r value. Now, I know that that's greater than 1, so I can say my r to the n, in this case it's 2 to the n minus 1, all over 2 minus 1. Of course, we could simplify this to being 1, which means that Sn equals u1, and u1 we know to be 5, don't we? So we can even throw the 5 in there. 5 times 2 to the power of n minus 1. And it's all over 1. So that's my kind of formula that I've got here for the nth term, also the sum of n terms. Now we do know that the sum of the n terms is 635. So now I can go that one step further. I can whack in that 635 equals 5 brackets 2 to the power of n minus 1. And then you can literally put that into your F3 solver. Some people like to do this into a graph mode and put this into a graph and see where it cuts it at 635 and all sorts of things. But to be honest, you've got your calculator, you can chuck it in and it will get you the answer. And literally, if you press your solve, you put it as the exponential equation, you come up with n equals 7. Answer. Okay, you don't need to put it back into anything at all. You know, that is simply what my question is going to be. So slightly more challenging, a little bit the wording in it. I guess what you're coming down to is that step process. And I might sum that up because this is the last lesson in terms of those first four things. The first step you have to recognize, is it an AP or is it a GP? Second step, are you trying to find the nth term, or are you trying to find the sum of the terms? You sometimes even might have a combination of both of those. All right, that's the nth term, and that's the sum of n terms. And then, of course, you need to make sure that you answer your questions. Answer the question. And I said sometimes it could be a combination of those two. And I'm just going to say, remember about the reversal questions, because you're seeing a lot more of those. And again, if you're looking for your 6s and 7s in studies, that's where those harder questions are going to come from. All right. Look, there will be one more video most likely in this series. That's where we're going to start looking a little bit at compound interest in series. But for the most part, that's where the majority of your questions are going to come from for these first 4 videos. I hope it's been useful. Please let me give me a bit of feedback if you need to. If you need some more help or something wasn't clear, please ask. But you need to do loads of these questions, get past papers, and just hit them out. Okay. As I always say, any problems, please drop me an email. Otherwise, have yourselves a great day.